Good day everyone, and hello sir. My name is Nicholas Pikayugan from BSN1 Batch 2. So today, I will be discussing about the three mathematicians and their contributions. So first, let's talk about Arthur Cayley. So facts about Arthur Cayley. Arthur Cayley was born on August 16, 1821 in Richmond, Surrey, UK. He died on January 26, 1895 at the age of 73 in Cambridge, England. His nationality is a British. Education at King College School and his alma mater, Trinity College, Cambridge, BA 1842. So, he known for algebraic geometry, group theory, Cayley-Hamilton theorem, Cayley-Dickson construction. Arthur Cayley, August 16, 1821 to January 26, 1895, was a prolific British mathematician who worked mostly on algebra. He helped found the modern British School of Pure Mathematics. He worked as a lawyer for 14 years. His father, Henry Cayley, was a distant cousin of Sir George Cayley, the aeronautics engineer innovator and descendant from an ancient Yorkshire family. He settled in St. Petersburg, Russia as a merchant. His mother was Maria Antonia Doughty, daughter of William Doughty. So second, let's talk about Richard Hamming. So Richard Hamming was born in Chicago, Illinois, USA on February 11, 1915, the son of Richard J. Hamming and Mabel G. Redfield. So he was brought up in Chicago where they attended school and realized that he was more able mathematician than his teacher. He wanted to study engineering, but the only offer of scholarship came from the University of Chicago, which had no engineering department. He entered the University of Chicago, receiving his BS in mathematics. So, after his undergraduate studies, he went to the University of Nebraska, where he was awarded in an MA in 1939. He received a PhD in mathematics in 1942 from the University of Illinois at Urbana-Champaign. His doctoral dissertation, Some Problems in the Boundary Value Theory of Linear Differential Equations, was supervised by Waldemar Jitsinski in 1901 to 1973. After earning his doctorate, Hamming married Wanda Little on September 5, 1942. He taught first at the University of Illinois and then at the J.B. Speed Scientific School of the University of Louisville. In 1945, encouraged by a friend, he joined the Manhattan Project at U.S. government research project to produce an atomic bomb at Los Alamos, New Mexico. In 1946, he accepted a position in the mathematics department at the Bell Telephone Laboratories in New Jersey. However, he didn't entirely break his link with Los Alamos Scientific Laboratories and made 2 weeks visit each summer as a consultant. At Bell Labs, he was able to work with both Claude Shannon, with whom he shared an office, and John Tukey. Some other young mathematicians had joined the mathematical research department at Bell Labs just prior to Hamming. So, this includes Donald Percy, Ling, and Brockway Macmillan, who had been at Los Alamos at the Hamming called themselves the Young Turks. He continued to work for Bell Telephones until 1976, although he became increasingly interested in teaching and held visiting or adjunct professorship at Stanford University, the City of College of New York, the University of California at Irvine, and Princeton University between 1960 and 1976. After retiring from Bell Labs in 1976, he became a professor of computer science at the Naval Postgraduate School at Monterey, California. He believed that the way mathematics was being taught was wrong, and that the only way to change it was to write textbook with a new approach. Here are two examples of his views on mathematics teaching. We live in an age of exponential growth in knowledge, and it is increasingly futile to teach only polished theorems and proof. We must abandon the guided tour through the art gallery of mathematics and instead teach how to create the mathematics we need. In my opinion, there is no long-term practical alternative, and the way mathematics is currently taught, it is exceedingly dull. In the calculus book we are currently using on my campus, I found no single problem whose answer I felt the student would care about. The problems in the text have the dignity of solving a crossword puzzle. Hard to be sure, but the result is of no significance in life. His attempt to move a new way of teaching calculus is exhibited in his 1985 book Methods of Mathematics Applied to Calculus, Probability, and Statistics. He said that the book is very different from the standard text, and the last mathematician is Claude Elwood Shannon, April 30, 1916 to February 24, 2001, was an American mathematician, electrical engineer, and cryptographer known as the father of information theory. Shannon is noted for having founded information theory with a landmark paper. So Claude Elwood Shannon was born on April 30, 1916 and died on February 24, 2001. Shannon was one of the people involved in the earliest experiments in artificial intelligence. He built an early illustration of AL, or at least as close as could, in the 1950s. It was the robotic mouse named Theseus, and it could navigate a maze and then remember its path through the maze. So, Claude Shannon is a famous American mathematician, electronic engineer, and geneticist, sometimes tried as the father of the information theory. Was an outstanding student, and after receiving in 1936 two bachelor's degrees, one in electrical engineering and one in mathematics, at the University of Michigan, he began graduate study at the Massachusetts Institute of Technology, or MIT, where he obtained the master's degree in electrical engineering and his PhD in mathematics in 1940. While in MIT, he worked on Vannevar Bush differential analyzer, or a mechanical analog computer designed to solve differential equations by integrations. That's all, and thanks for watching!